Blessed is he who learns how to engage in inquiry, with no impulse to harm his countrymen or to pursue wrongful actions, but perceives the order of immortal and ageless nature, how it is structured. These words are those of a poet named Euripides. They were sung in 400 BC by the chorus in a play performed in an outdoor theater, built by citizens of the world's first democracy in ancient Greece. The general spread of the light of science has already laid open to every view the palpable truth that the mass of mankind has not been born with saddles on their backs, nor a favored few booted and spurred, ready to ride them legitimately by the grace of God. These words are those of Thomas Jefferson, Enlightenment philosopher and one of the founding fathers of the first modern democracy in the United States of America. Well, this light of science, this blessed inquiry, is indeed central to the blessings of democracy. How so? Well, let's trace the connections. Science got its start at the same time religion and capitalism got their start, in prehistoric times. 100,000 years ago, our Homo sapiens ancestors lived in caves and rude shelters. These first humans survived by hunting, fishing, and gathering wild foods. Anthropologists have been able to learn quite a bit about these ancestors by analyzing bones, tools, and other remains in burial sites, as well as by studying primitive tribes still surviving today in remote regions of the Amazon, the South Pacific, and Africa. Now, partly because of a high rate of violence, but also because of high rates of starvation, malnutrition, disease, and accidents, they found that the average life expectancy was less than 30 years. And yet, surprisingly enough, they found that people then may have had more leisure than most people do today. Homo sapiens individuals of 100,000 years ago had minds pretty much like ours today. They used this mind and a unique hand, unique among animals in having an opposable thumb, to invent tools like fire, spears, bows and arrows, better kinds of shelter, and new and better ways of hunting, fishing, and gathering wild foods. In the broadest sense, science and technology were born. In some parts of the world, around 10,000 years ago, some humans made a major advance using these same science and technology skills. They found ways to grow food and husband animals. The agricultural revolution began, and over the next few thousand years, it spread to all the continents. This agricultural revolution has lasted 10,000 years, all the way up to the 21st century. In many parts of the modern world today, not everywhere, it has been replaced by an industrial revolution that began only a few hundred years ago. During this long 10,000-year time, many civilizations in Africa, Asia, Europe, the South Pacific, and the Americas rose and fell. All of them made advances in what we would today call science and technology. Weather, seasons, soils, sun and stars are all of prime importance in agriculture as well as in navigation on land and sea. And all agricultural kingdoms on all continents made discoveries important to the beginnings of earth science, astronomy, and chemistry. All agricultural kingdoms, by necessity, also learned more about the natural living world of plants and animals, and so laid a base for what would come to be called today the life sciences of biology, ecology, and agriculture. Unfortunately, all agricultural civilizations also fought frequent wars with one another, and in the process laid a base for much of what would today be called physical science, engineering, and metallurgy. Similarly, all kingdoms by necessity learned more about the human body and about disease and health. Even though much of this knowledge, like their knowledge in earth sciences, astronomy, and biology, was entwined with magical and religion-based error, it was the beginning of what we would today call medicine. The Chinese people in particular created a rich civilization that for many centuries surpassed all others in science, in the arts, in organization, and in trade. The first printing presses, the first magnetic compasses, the finest ceramics and metalwork, gunpowder, porcelain, silk, and paper, the largest and best sailing ships all came to the world first in China. Similar advanced agricultural kingdoms flourished in India. One of the most important scientific ideas from India was the invention of what came to be misnamed Arabic numerals, 1, 2, 3, 4, 5, and so forth, including the most important numeral of all, 0. All of these agriculturally based ancient civilizations had political systems that featured strong class divisions, powerful religions, slave labor, frequent wars, and tyrannical governments. Unfortunately, most of these traits worked against more rapid progress in what we today call science and technology. Reliance on slave or serf labor, for instance, universal in all agriculturally based civilizations, made for little incentive to improve technology. Why bother when there were plenty of slaves or serfs to do the work? Powerful religions, too, did little to encourage unbiased inquiry into the mysteries of the natural world. A god or gods made the world the way it is. Humans can do nothing about this, except perhaps pray to the gods to bring peace and prosperity and to take away pain and adversity. An early 6th century Christian bishop and philosopher in North Africa, later canonized as St. Augustine, put it this way: there is another form of temptation, even more fraught with danger. This is the disease of curiosity. It is this which drives us to try and discover the secrets of nature, those secrets which are beyond our understanding, which can avail us nothing, and which man should not wish to learn. Well, similar opinions were held in most other religions. To inquire why or how might offend the gods. And since tyrannical governments relied on religious myths to enhance and uphold their power, science and invention were again the losers. In fact, the sad truth is that frequent wars were one of the few places where there were natural incentives to improve weaponry, and were thus a boon to science and invention. At least one agriculturally based civilization in the ancient world did do more to encourage unbiased inquiry into the natural world, as well as to introduce a new way of governing. That rare combination of natural science and political innovation was in ancient Greece, and it turned out to be a powerful inspiration for civilizations of much later times. A few hundred years before the birth of Jesus, in small city-states like Miletus, and later in larger city-states like Athens, a new idea for governing, based on reason and experience, was tried. The Greeks called it democracy. Here in Athens, for instance, every citizen would gather in the center of town to pass laws, make judgments on disputes, assess taxes, and vote for war or peace. The duties and offices of government were assigned by lot. Every citizen was free to pursue his own interests so long as they did not interfere with others, and every citizen had the right to his own private property. This direct democracy of the ancient Greek city-states did have severe limitations. While citizens of the city-state were free and equal, citizens did not include women, nor did it include slaves. At the height of Athens' democratic glory, out of an estimated population of 400,000 people, there were only about 40,000 citizens. Even for these citizens, it was a democracy of majority rule, with little attention paid to the rights and civil liberties of minorities. One of their most illustrious citizens, for instance, a philosopher named Socrates, was sentenced to death for, quote, corrupting the youth, unquote. There were as yet no such thing as inalienable rights. The Greek democracy, however, did nourish an environment that encouraged rational inquiry. Natural philosophers like Thales, Anaximander, Plato, Aristotle, Pythagoras, and Hippocrates were among the first humans to look at the natural world and try to construct theories to explain why and how it worked the way it did, without invoking supernatural powers. Probably because of their reliance on slave labor, these early natural philosophers never quite made the solid connection between theory and experiment that characterizes modern science, but it was a start. Rome, founded as a small city-state in Italy, began as an aristocratic republic. Rome borrowed and built on some of the cultural riches of Greece, and in some important ways advanced its democratic ideas, as well as improving some technologies and advancing science. In the process of founding and governing their empire, for instance, the Romans developed a system of Roman law based on nature and reason that has had great influence in the Western world. Romans were also the first to separate the government into executive, legislative, and judicial branches. Romans were also the world's greatest engineers when it came to roads, water supply, sanitation systems, and civic architecture, as well as the world's greatest bureaucrats when it came to administering their empire. Well, the enduring ideas that led to these achievements have had and still have great influence in the Western world of today. We still speak of senators, councils, constitutions, republics, all words derived from their Latin Roman roots. Travel to Paris or London or Berlin or Ottawa or to Washington, and you will see many examples of the Roman architectural influence. Unfortunately, as Rome prospered, it became more imperial and tyrannical. It grew into an empire that eventually included most of the land around the Mediterranean Sea, going as far north as Great Britain, as far east as Persia, and as far south as North Africa. Slavery also increased as equality and liberty were crushed under the boots of the marching imperial legions. In the 5th and 6th centuries A.D., the Roman Empire collapsed and splintered into a multitude of small feudal states, often at war with one another, and there followed a serious decline in living standards for the elite rulers. The peasants, serfs, and slaves had always had a subsistence life, of course, but even that life became more precarious in what followed, sometimes called the Dark Ages of Europe, from the 5th to the 11th century. Now, many historians today who have made studies of this time in Western Europe dislike that term. Instead, they call the entire period from the fall of the Roman Empire to the Renaissance in northern Italy in the 14th and 15th century medieval, divided into early medieval and late medieval. Well, whatever you call it, during this long 1,000-year period, science did make some advances in the Western world, even though it lagged behind the Islamic Indian and Chinese civilizations for many centuries. What the Western world did have that the other civilizations lacked, though, was a culture that gradually abandoned slavery, a culture that gradually came to respect women, at least far more than any other non-Western cultures did, and some scholars think most important of all, a culture that began to accept reason as an important route to understanding and truth. Reason was not the only route, to be sure. Divine revelation was still given first place, as it was in almost all agricultural kingdoms, but nevertheless, reason was a valued and necessary virtue. This last trait, respect for reason, was not absolute. Thomas Aquinas, considered the greatest of the Roman Catholic philosophers of medieval times, struggled to reconcile the natural reason of Greek philosophers like Plato and Aristotle with divine revelation from the Christian Bible. Philosophers a few hundred years later, in what is called the Western Enlightenment, would build on his work with natural reason, but discard the need to reconcile reason with revelation. For most people, life was a desperate struggle for survival in the Middle Ages. Christian monasteries, and later the first universities in Europe, sometimes managed to escape the worst of the chaos, poverty, and ignorance. In these universities, logic, reason, and a respect for learning were kept alive. In the monasteries, slow but steady progress was made in technology and science as well, and indeed an early form of capitalism was invented. Wheelbarrows, rotation of crops, the spinning wheel, heavy plows, better horse collars that enabled a medieval horse to do 10 times the work that a Roman horse could do without choking itself. Water wheels and windmills. By 1080 in England alone, the Domesday Book recorded 5,624 water mills in operation. Monasteries also stimulated a closer contact between work and thought, where the power of practical invention could be yoked with the wonder of God's world. They believed it was a world one could understand with the gift of reason if one worked at it. And it was in these monasteries, as well as in the universities of the later medieval times, that scholars like Gerald of Cremona spent their lives translating works of ancient authors like Aristotle, Euclid, Ptolemy, and Archimedes, translating them from the Arabic, note the Islamic contribution, into the scholarly language of the West, Latin. Monasteries also began to experiment with production for profit in free trade, becoming some of the world's first capitalists. And they also formed banks that lent money to the Pope, as well as to other monasteries and to nobles and kings. Well, all of this scholarly and technical progress in Christian monasteries and universities laid the base for a remarkable flowering of human invention and progress in what is called the European Renaissance. And it was in the 16th and 17th century Renaissance Europe that modern science was born. In northern Italy, a man named Galileo Galilei was one of the most important of the new natural philosophers who for the first time did combine natural reason with experimental observation. We call him today one of the world's first scientists, though that name was not used while he was alive. Galileo, along with other science pioneers like Nicholas Copernicus, Johannes Kepler, and a little later Isaac Newton, changed radically the way human beings looked on the world and began a quest and a revolution that is still going on today. Before Galileo's time, for instance, everyone in the world knew for sure that our Earth was the center of the universe. Everyone knew for sure that the sun and stars were out there, some fixed and some revolving around our central stationary Earth. The thoughts and experiments of these first scientists proved that what everyone knew for sure was not true. The Earth is not standing still, nor is it at the center of the solar system, much less the universe. Instead, the Earth, they proved, was moving, and very fast. It was, in fact, spinning around once every day on its own axis. And instead of being at the center, it was also moving around a central sun, taking 365¼ days to make a complete circuit. Later astronomers proved that even this solar system of ours is only a tiny part of the wider Milky Way galaxy that has billions of stars in it, and this Milky Way galaxy is itself moving as only one of billions of galaxies in the known universe. Quite a change, you'll have to admit, from what everyone knew was true just a few hundred years ago. And if all of that was true, and their experiments and reasoning were convincing to anyone who took the trouble to investigate, it was a serious challenge to all religions of that day. All religions, as well as pretty much all human beings, had always assumed we on earth were special, central to God's plan. And indeed, Galileo was brought before a church court of the Inquisition and convicted of heresy for claiming that the earth was not the center of the universe. Faced with such a serious charge as heresy that could lead to his being burned at the stake, Galileo recanted and was let off with house arrest on condition that he refrained from making such absurd claims again. Other thinkers, like the Catholic monk Giordano Bruno, who refused to deny their scientific convictions, were convicted of heresy. Bruno, for instance, was brought to a central Roman market square, his tongue in a gag to prevent him from spreading his heretical views, tied naked to a pole and burned at the stake on February 17, 1600. Well, despite the efforts to suppress it by the church and secular authorities, the explosion of interest in this new way of thinking, science, began to spread over the next centuries, first throughout Europe and later throughout the entire world. This interest and its consequences were very powerful for two reasons. One, science worked. That is, it did lead to new knowledge and to new technologies that were of obvious benefit to people. And two, science had a new way to spread its working knowledge, the newly invented printing press. The work of Galileo, Copernicus, Kepler, and Newton, and the physicists and chemists and earth scientists who followed them, soon led to better calendars, better maps, better artillery, better vehicles, better mines, better sanitation, better machinery of all kinds, huge increases in available energy, and eventually to electricity, automobiles, airplanes, Earth satellites, computers, and the Internet. Similarly, the work of life scientists like ANDREAS VESALIUS in Italy, William Harvey in England, Anton von Leeuwenhoek in Holland, Louis Pasteur in France, Robert Koch in Germany, and Charles Darwin in England soon led to less disease, better crops, less pollution, better understanding of the human body and brain, an enormous increase in lifespan from 30 to more than 70 years of life for the average human being. And in the case of Charles Darwin, it led to a revolution in the way educated humans viewed the natural organic world, just as revolutionary as the one started by Galileo, Copernicus, and Newton. Well, this remarkable progress might not have happened had it not been for that late medieval invention, the printing press. Had it not been for printing, the insights of Copernicus might have gone unnoticed for centuries by the world at large. That was, after all, the fate of many of the insights and inventions of the Chinese, Islamic, Mayan, African, Indian, and Japanese thinkers and inventors of earlier centuries and civilizations. Because of printing publications after 1450, ideas and inventions would be shared comparatively quickly and widely throughout the literate world. And so they were. What does this scientific and technical progress have to do with democracy? Well, let's explore that question in part 2 of this program.